Okay, so for each of these, you're going to figure out what you're going to do. All right, this is the rule that I say you take the outside times the full length is equal to the outside times the full length. The issue is, can you remember that the full length is x plus 8, not just x? Okay, outside times the full length is equal to the outside times the full length. Okay, here we have a radius cutting through a chord. Here is part of the arc. Here's the other part of the arc. Your answer is 42 degrees because this is perpendicular to this chord, which means it cuts this arc in half, and it also cuts the chord in half. So as soon as you see that's perpendicular, you have bisected your chord and you have bisected your arc. Same rule we've already talked about. Outside times the full length is equal to the outside times the full length. Oops. So the outside is 5, the full length is 5 plus x is equal to the outside, which is 6, and the full length is 14. I've made up these numbers, so if you try solving, it could be a disaster. I want you to know how to do the first step. Oh, look it's a radius, and there is a perpendicular line. Your chord has been bisected, so your value of x should be 10. All right, we have a center. It's equal distance to this chord as it is to this chord. There's a rule that says if you're equal distance, then your chords are going to be congruent. So the value, or the distance from C to D, is 10. All right, we have two chords cutting through our circle. It could be drawn as secants, but in this case I have chords. All right, we're going to take this piece times this piece equal to this piece times this piece. Please don't try to solve, just set it up. 8x is equal to 10 times 5. All right, we have an inscribed quadrilateral. There is a rule that when you take the opposite sides on an inscribed quadrilateral are supplementary, which means they add up to 180. So 120 plus 60 is equal to 180. Okay, I want to figure out x. I'm going to take my, this is where don't be an aardvark. Take 1/2 times your large arc minus your small arc. So your large arc is 330. That leaves 30 for your small arc. Take it times 1/2, and that gives you the angle. All right, your radius comes out here to meet a tangent line. This is the point of tangency. I want to figure out angle ABC. Anytime a radius meets your point of tangency, you have a 90-degree angle. All right, we have an angle, a secant, and a tangent. The large arc minus the small arc, take it times 1/2, that's equal to x. All right, so you're going to take 1/2 times the large arc, which is 160. Your small arc is 40. That'll give you the value of x. All right, this is an external point. I have a tangent line and a tangent line coming from an external point. The rule is when those are congruent, when you have two tangents coming from the same external point. All right, here's your angle, here's your large arc. I wonder what the small arc could be. Okay, we're going to take 1/2 times the large arc minus the small arc. So the large arc is 300, that leaves 60 for the small arc, and that'll give you your angle right here. Okay, this is the one that I think everybody's going to forget. You have an angle in here, we have an arc and an arc. We want to figure out what the angle is. This time, we are adding our two arcs together and dividing by 2. So 80 plus 30, take it times 1/2, that gives you your angle in the middle. Okay, and that is the end.